Welcome to 10.5, rotation of axes and the general form of a conic. So first we're going to identify a conic. We're going to use a rotation of axes to transform our equations. We will analyze an equation using rotation of axes and identify conics without rotating the axes. Number 3, that objective is done more throughout the text. So if you need more clarification on that, go ahead and reference the text, which you should have already completed your reading on. Okay, so first up, let's identify the equation without completing the square. So without putting it into any different sort of form, can we identify what this is an equation of? Well, using what we know that this is our a value. This, since it's on the y squared, it's our c value. Negative 2 on the x is our d value. The 8 on our y is our e value. So, using our theorems, we know if a times c equals 0, well, let's figure it out first. We have a, 5, c, 8. This is 40. This is not equal to 0, so it's not going to fit that theorem. Next up, our next test, we need to check AC, which equals 40. Is it greater than 0? And yes, it is. That tells us this is an ellipse. And it's easy as that. Just go through each of those checks that we need to make. The biggest thing here is make sure that you're labeling the correct letters in terms of which coefficient it is. Yeah, and then as long as you follow those theorems, you will determine what the equation is of. Here, let's determine the appropriate rotation formulas to use so that the new equation contains no xy term. So we want to get rid of the x times y. So this tells us our a is 1, our b is 18, and our c is also 1. And the formula we're going to be using is cotangent to theta equals a minus c over b. Let's plug in what we know. We have 1 minus 1 over 18, which is 0. That tells us cotangent of 2 theta equals 0. Now, when is cotangent 2 theta 0? Well, that tells us that 2 theta is 90 degrees. So theta, 1 theta, is 45 degrees. Now that's really nice because when we rewrite it using x is our x prime cosine theta minus y prime sine theta, and then our y is x prime sine theta plus y prime cosine theta. Our sine of theta, our cosine of theta are going to be the same because our theta is 45 degrees. At 45 degrees, what are sine and cosine? Well, our sine and cosine are both root 2 over 2. So root 2 over 2x prime minus root 2 over 2 y prime. And then y is going to be root 2 over 2 x prime plus root 2 over 2 y prime. And those are the rotation formulas. Okay, this lecture is quite short and straightforward. This is our last example. Identify the equation without applying a rotation of axes. X squared plus 4xy minus 7y squared plus 8x plus 4y plus 5 equals 0. So I'm going to label everything. We have A, we have a B, C, D, E, and this time we even have an F. So these are based off of the coefficient in front of our values. So A is in front of the x squared, B is in front of the x times y, C is in front of the y squared, D is in front of the x, E is in front of the y, and F is the constant. Now, we're looking for B squared minus 4AC. Now, B squared minus 4AC is going to be 16 minus 4 times 1 times negative 7. And 16 minus 4 times 1 times negative 7 gives us 44. Now, looking at our theorems, 44 is greater than 0, which puts this guy at hyperbola. And so we have identified it. We didn't apply any rotation of axes. We didn't use any completing the square. We didn't rewrite it at all. We just used the coefficients and our theorem to determine it is a hyperbola.